Well, here's a brief introduction to the time value of money concept. On your computer screen, you'll see a gentleman by the name of Martin de Aspilcueto. Aspilcueto is reported to be the possible founder or inventor of time value of money. And I'm going to go ahead and start with just a quick timeline. In my timeline, I'm going to go ahead and put a present value here and just a future value here. And what the concept of time value of money is, it attempts to compare cash amounts at different times. And in order to do that, we need only two more pieces of the equation here. The first one we'll need is some type of rate of increase. And I'm going to go ahead and place it here as an R. And we're going to need an amount of time that it increases. I'm going to close this off and put it in. And the one thing we also need is the letter 1, because if I multiply, like, let's say 10% by $100, I only get $10. So I need my $100 back, so I put a 1 here and I put a plus. And now we have created or reproduced the equation to find the future value from a present value. And in the eyes of time value of money, they are equal at that rate and that time. We can do the opposite, or find the present value, by using that rate. Now up here I call the rate compounding. Down here I'm going to call it discounting. So here I can say I can find the PV if I have an FV. All I need again is the rate and the N. Now the way we undo multiplication with division, so I can actually divide 1 plus R into the future value, but I find it easier just to go ahead and reproduce the same formula up here and just raise it to the negative N, and that's referred to as its reciprocal. It's a little easier, so that this number in here will be less than 1, hence the future value will, when you multiply a number by less than 1, the future value will be less, the present value will be less than the future value. There's one more piece of equation, one more number we need on this timeline to complete it. We have maybe possibly payments. And I'll just put 3 payments here. Now we refer to payments as annuities if they're the same. So I'm going to call them annuities and payments alike. So let's go ahead and say, what if we have payments and I want to know the future value? Well, let's do future value. And instead of starting with the present value, we have to start with a payment. And the equation is very similar, but just a slight bit different. First of all, I have my 1 plus R, and I have my N. That 1 plus R is going to be in every time value equation. The only difference now is I have to, when I get that number, I subtract a 1 from it, and I divide the whole thing by R. And now with this, whatever that number is in here, I multiply by the payment. So for instance, that's $100, $100, and $100. The future value is going to be greater than $300. And if I fill in this equation and multiply that by 100, I'll get my future value of an annuity. Now let's try it again, but now let's see if we can find the present value of an annuity. Well, again, we're going to have to start with the payment. So what we're looking for is this one here, so of annuity or payment. So the equation is very similar. There's the 1 plus R. Now I got to raise it to the negative N, the reciprocal, like down here. The only difference now is where this 1 was here, I subtract a 1 from it. I just subtract the whole number by 1 and divide that by R. And this equation multiplied by the payment will give you the PV. So I may say, what is the present value of 3 $100 future payments? And remember, in the eyes of time value of money, those are equal. Now, these 4 equations make up perhaps the majority of all of finance. I might want to play with the rate a little bit, and if I play with the rate, we refer to a nominal or quoted rate, compounding once a year, but I might want to compound it more, which will increase the future value. And in the real world, that's what banks do. Banks will usually compound it either daily or continuously, and there is an equation for that. It's a quite simple equation. Now, a lot of your computer Excel will find the answers to any of these. So if you stop, it's real easy formula-wise to find the present value or the future value of either payments or a lump sum with these 4 equations. The issue becomes, what if I'm looking for the rate? Like I have $1 and it triples over 5 years. What rate would that be? In order to use these equations, we have to use algebra and solve for R. So I find it much easier when I'm looking for either rate or payment or N to go ahead and use like some type of Excel spreadsheet or Hewlett-Packard 10b2 or one of the Texas Instruments calculators. I hope this helps understand the concept of time value of money.